welcome to VChem World. Today we are going to discuss about the pH of the strong acid and strong base. First of all, what is the meaning of the pH? pH means the potential of hydrogen. How to define the pH? pH is equal to minus log 10 base H plus concentration. Minus log concentration of the H plus. This is known as the pH. The same way POH is equal to minus log base 10 OH minus. So this is the concentration of the OH minus. This POH for the base and pH for this acid. But we know that in this pH scale 0, 7 and 14 means pH scale 0 to 14 number present. So for this 0 to 7, this is the acid. 7 to 14, this is the base. And 7 is neutral. Neutral means that the acid and base same composition. Where is the acid? So acid range is 0 to 6.99 and base range is the 7.1 to 40 because of the 47 is neutral. So that way we know that the acid 0 to 7, 7 is a neutral and base is the 7 to 14. This is the pH scale. Next, for the strong acid and base, what is the meaning of the strong acid and base? First of all, what is the meaning of the acid? Acid that donate H plus in aqueous medium. Aqueous medium, that means the H2O. So when donate H plus in aqueous medium is known as the acid. Same as the base donate OH minus in aqueous medium. This is known as the base. So remember that the H plus donate acid, OH minus donate base. So that way this is the acid and base. And one more, strong. Where is the strong refers for this? This is the completely dissociate. Where acid is 100% dissociate into its ion, it's known as the strong acid. For example, consider HCl in the aqueous medium converted into H plus and Cl minus. Consider 100 molecule of the HCl, where this converted into 100 H plus and 100 Cl minus. So that way 100 HCl converted into 100 H plus and 100 Cl minus. So it's completely dissociate into this ion. So it is known as the strong. Whereas the completely dissociate into H plus ion, it's known as the strong acid, and completely dissociate into the OH minus ion. So it's known as the strong base. So that way pH of strong acid and strong base, that means the completely dissociation of the acid and base. The pH of strong acid, we know that the pH is equal to minus log 10 base H plus concentration. As we put the value of the H plus, so we find out the pH value. For this 10 raised to minus 2 molar HCl. Where first know about the HCl dissociate into H plus and Cl minus. Its concentration 10 raised to minus 2 molar. This is the 10 raised to minus 2 and also 10 raised to minus 2. Why this is value is the 10 raised to minus 2? Because of the HCl has a 1 mole. Where HCl dissociate into H plus and Cl minus. So it's produce the 1 mole of H plus and 1 mole of Cl minus. So that way this concentration is same as this concentration because of this same mole. So pH is equal to the minus log H plus concentration. Minus log 10, H plus concentration is 10 raised to minus 2 molar. Where this 10 raised to minus 2 molar. So this minus 2 and this minus 2. This is the plus 2 log 10. Log 10 is value is 1. So pH is equal to 2. That way we find out the pH of this HCl. Next is the 10 raised to minus 2 molar H2SO4. First write that the H2SO4 completely dissociate into the 2H plus and SO4 minus 2. its concentration is 10 raised to minus 2 molar. This is the same 10 raised to minus 2 molar. But in this case, 2 into 10 raised to minus 2 molar. Why this is the 2 into 10 raised to minus 2 molar? Because of in the H2SO4, 1 mole of H2SO4 converted into 2 mole of H plus. So mole is double, so its concentration is double. So that way multiplication with 2 into 10 raised to minus 2 molar. Put this value in this equation. So pH is equal to minus log H plus. Where is the minus log H plus value? 2 into 10 raised to minus 2 molar. Solve this equation. Minus log 2 plus minus log 10 raised to minus 2. And minus log 2 value is equal to 0.30. This is the minus plus this minus 2 and plus 2. So its value is 2. 2 minus 0.30. This value is 1.70. So 10 raised to minus 2 molar of H2SO4 value is 1.70. And same as the 10 raised to minus 2 molar of HCl value is 2. So difference between the pH of these two acid depends on this H plus concentration. Because of this is the monobasic and H2SO4 is dibasic. Monobasic means 1H plus and dibasic means 2H plus. So that way difference in this the pH for the HCl and H2SO4. The pH for the 0.1 normal HCl and 0.1 normal H2SO4. This value given in this the normality. So concentration given is normality. Always remember that they find out the pH value is always concentration present in this the molar concentration. For the molarity, that means the moles per liter. So first convert it into normality into molarity. So normality is equal to X into molarity. This X for this acid, that means the ionizable H plus ion. We know that in the HCl converted into H plus and Cl minus. So ionizable H plus ion is 1. So put this value 1 into molarity value find out. So normality is equal to 0.1 molarity. Molarity is equal to 0.1. Then use this value for this calculate the concentration of this pH. So pH is equal to minus log H plus. This H plus for this 0.1. So minus log 0.1, write the 10 raised to minus 1 molar. This minus 1 and this minus converted into plus. So this pH value is equal to 1. Next is the 0.1 normal H2SO4. So normality is equal to X into molarity. Where is the X is the ionizable H plus ion. In this H2SO4 is a strong acid, so it is the completely dissociate into its ion. Whereas the H2SO4 dissociate into 2H plus and SO4 minus 2. So ionizable H plus ion is 2. So put this 2 value in this equation. 2 into molarity and normality value given is 0.1. So molarity is equal to 0.05. That means this is the 0.05 molar H2SO4 solution. So H2SO4 converted into 2H plus SO4 minus 2. 5 into 10 raised to minus 2 molar. This is same for the 5 into 10 raised to minus 2. 5 into 10 raised to minus 2 molar and 2 into 5 into 10 raised to minus 2 molar. So this is the 10 raised to 10 into 10 raised to minus 2 molar. So this value is the 10 raised to minus 1 molar. Where this value is the 10 raised to minus 1 molar. Put this value in this equation. So pH is equal to minus log 10 H plus. So H plus value is 10 raised to minus 1 log 10 raised to minus 1. This value and this value is same. So pH is equal to 1. So that way 0.1 normal HCl pH is equal to 1 and 0.1 normal H2SO4 pH is equal to 1. Why 0.1 normal HCl pH value is 1 and 0.1 normal H2SO4 value is 1? Because of in the H2SO4 first normality divided by 2, So this gives this value 0.05 and also multiply with this 2. First divide and then multiply with the same value. So this gives the 10 raised to minus 1 and its answer is pH is equal to 1. But in this the molarity, 0.1 molar of HCl and 0.1 molar of H2SO4, its value is a difference because of the, in this case concentration is molar, but in this case concentration in normality. Next is the find out the pH for the monobasic, dibasic and tribasic. For this short trick is the monobasic, that means the 1, dibasic that means 2 and tribasic that means the 3. For the monobasic, that means 1H plus H2SO4, for example H2SO4 is a dibasic acid, so 2H plus, and tribasic acid H3PO4, so this is the 3H plus. Where is the H plus 1? So it's multiply with 1. This concentration 0.1 molar. Dibasic, its concentration 2 into 0.1 molar and tribasic 3 into 0.1 molar. So monobasic always put same value as the concentration, dibasic multiply with this 2 and tribasic multiply with this 3. So put in this equation pH is equal to minus log H plus this value, and this is the pH is equal to minus log 2 into 0.1 and pH is equal to minus log 3 into 0.1. So that way difference in the monobasic, dibasic and tribasic because of the ionizable H plus ion. This is the 1, this is the 2 and this is the 3. So that way this concentration is different and pH value is also different. HCl 10 raised to minus 7 molar HCl and 10 raised to minus 8 molar HCl. We know that the pH scale 0 to, this is the 7, 0 and 14. 0 to 7 acid, 7 to 14 is base. So we can say that the pH less than 7, this is the acid, and pH greater than 7, so this is the base. Because of the pH greater than 7, 7 to 14 base, and less than 7, this is the acid. Where pH less than 7, so its concentration of the H plus is equal to 10 raised to minus 7. But in this the less than 7, so this is the 10 raised to minus 7, less than the 10 raised to minus 7. Where this value given is the 10 raised to minus 8 molar HCl. It means that this value always present less than 10 raised to minus 7. But this is the 10 raised to minus 8. So this value is the very dilute solution of it's less than 10 raised to minus 7. That means this value is 10 raised to minus 6, 10 raised to minus 5, 10 raised to minus 4 up to 10 raised to minus 1 value. But greater than 10 raised to minus 8, 10 raised to minus 9, 10 raised to minus 10 is not possible. But in this case given is the 10 raised to minus 8 molar HCl. That means this solution is very dilute solution of HCl. Where is the very dilute solution of HCl? That means the H2O is more. Dilute solution and concentrated solution. Concentrated solution, that means the where the solution in the solution solute is more. This is the concentrate. In this solution solute is less. That means this is the dilute solution. So this is the very dilute solution. That means the HCl concentration is very low. HCl concentration is very low. How to find out the pH value for the 10 raised to minus 8 molar HCl? So, very dilute, that means more amount of the H2O present. And we know that the H2O concentration is 10 raised to minus 7. For this equation H plus is equal to 10 raised to minus 8 plus 10 raised to minus 7. Because of the 10 raised to minus 8 molar HCl is very dilute solution. For the dilute solution, in this dilute solution, H2O amount is more. So 10 raised to minus 8 plus 10 raised to minus 7. Put this value in this equation, pH is equal to minus log base. pH is equal to minus log base 10 H plus. minus log 10. H plus is equal to 10 raised to minus 7 plus 10 raised to minus 8. Minus log, common value is 10 raised to minus 8. So this is the 10 plus 1. So minus log 10 raised to minus 8 minus log 11. 10 plus 1, 11. This minus and this minus is a plus. So this is the 8 and log 10, 1. So minus log 11. Log 11 is 1.04. So this value is a 6.96. pH is equal to 6.96. 7 molar HCl. This value for this neutral, not for the HCl. But given value is 10 raised to minus 7. How to solve this? Same for this. H plus value is equal to given is 10 raised to minus 7. And this is the diluted solution of the HCl. So its value is 10 raised to minus 7. Put this value, pH is equal to minus log 10 H plus. Minus log 10. This is the 10 raised to minus 7 plus 10 raised to minus 7. Common 10 raised to minus 7. And this is the 1 plus 1, 2. Minus and minus plus 7 minus log 2. And this is the 7 minus log 2 is 0.30. So this value is 6.70. This value, this is the near to the 10 raised to minus 7 value. So this is the also diluted solution. So same way apply this formula. H plus is equal to 10 raised to minus 6 plus 10 raised to minus 7. pH is equal to minus log H plus. This is the 10 raised to minus 6 plus 10 raised to minus 7. Minus log, common value 10 raised to minus 7, 10 plus 1. Minus plus, minus minus plus 7 log 10, 1 minus log 11. 7 minus log 11 value is 1.07. So this value is 5.96. So that way we say that the 10 raised to minus 6 molar HCl value is 5.96. 10 raised to minus 7 molar HCl value is 6.70. And 10 raised to minus 8 molar HCl is 6.96. So conclusion that the where concentration of this HCl is decreased. Concentration of the HCl is decreased. So its pH value is increased. Concentration of H plus is decreased and pH value is increased. More concentration, so pH value is less, and low concentration, so pH value is more. So that way same, HCl is same, but its dilution is more. This is the 10 raised to minus 6, this is the 10 raised to minus 7 and 10 raised to minus 8. Where dilution is more, so H plus concentration is decreased. Where H plus concentration is decreased, so pH value is increased.